Welcome everybody to this chapter review video. Remember, the purpose of this video is to help you review before you take the exam. So the best way to do it is to first review the individual sections in this chapter. You can go back in our notes, you can watch our previous lecture videos. Make sure you're comfortable with the content. Do you have the formulas that you need gathered close to you? Do you have your calculator? Once you have all that, attempt the problems on your own. Only when you've attempted the problems, watch the solutions to check your work. So if you would, take a moment, pause the video, attempt this problem on your own, unpause to see the answer. So here we're asked to find the critical value T alpha over 2. Now, we know in this class we really need to pay attention to small details. This small detail of T alpha over 2 as opposed to Z alpha over 2. The fact that we're seeing T alpha over 2 tells me I'm not using my cumulative normal distribution chart. Instead, I need to use the student's T distribution chart. And we're asked to construct the confidence interval for the given sample size at the given level. So here I've got 95% with a sample size 23. I know when I'm dealing with the student's T distribution level, you immediately take the sample size and you find the degrees of freedom. Degrees of freedom is 1 less than the sample size, so here that's 23 minus 1 is 22 degrees of freedom. Now, in terms of what does this level 95 mean? Well, here I've got my normal curve. And I'm interested in the middle 95% here. Now I know if this is 95% of the whole, the remaining tail to the left and the right makes up the remaining 5% symmetrically. So 5% over 2 equal pieces is 2.5% in each, or an area value of 0.025. Similarly here, I could have my 2.5% or an area value of 0.025. Now we need to bring up our student's T distribution table. So here I've just visualized my 95%. Now in this chart, we're looking at the 95% confidence level, which we can see is this column. And then the way we choose which value is based on our degrees of freedom. So our degrees of freedom was 22, so we look at the 22 row intersecting the 95% column, and we coordinate both of those. We get a T alpha over 2 value of 2.074. Okay, let's go to the next one. We'll repeat this process. Now we've got a 90% with a sample size 3. So here I know my degrees of freedom. 1 less than the sample size, so that's 3 minus 1. That would be 2. Okay, we bring up our chart. Now here we're looking at 90%, which is this column. Degrees of freedom 2, and we see that value is 2.920. And using this method, we've now found our critical value for this, confidence interval. How do you visualize what this critical value is? Well, if we actually drew this, since it's 90%, this is just to help us synthesize. We've got our answer, now we're just interpreting it. Here's my 90% in the middle. You know the remaining portion accounts for the final 10% split in 2 equal pieces. So you've got 5% here, which is 0.05 area, 5% here, which is 0.05 area. So this T alpha over 2 value of 2.920 means this is negative 2.920. This is positive 2.920. We found the z-score. The z-score with area to the left, that's 5% of the curve, is negative 2.92. The z-score with area to the right, that's 5% of the curve, is 2.920. Similarly here, this z-score would be negative 2.074. This would be positive 2.074. So if you would read through the example, attempt A and B, and then pause the video, unpause to check your work. So here I've got a sample of 263 students. We're taking an online course. They were asked to describe their overall impression from 1 to 7. 7 is most favorable. Average score was 5.53. Standard deviation is 0.92. Now, from the way this is phrased, this is the average score from the sample, standard deviation from the sample. So extracting this information, I get the sample size is 263. Sample average is 5.53. Sample standard deviation is 0.92. Okay. Construct a 95% confidence interval for the mean score. Well, if you look back in our notes from this section, you'll find the relevant formula. Remember, in this class, you've got to be able to identify the formulas. Without the formulas, we can't make progress. So let me write down the formula for this confidence interval. Okay. So this is our general formula. Now, we know the following. X bar is 5.53. S is 0.092. Excuse me, 0.92. I added an extra 0 there. N is 263. So the only thing that remains before we can evaluate this formula and find our confidence interval is this T alpha over 2. And we know that's our critical value. We'll find the critical value as we did in the previous two examples. So we cared about a 95% confidence interval, but our degrees of freedom here is 1 less than the sample size. So that's 263 minus 1, 262. Let's bring up our chart to find our T alpha over 2 value. So here we're interested in 95%. We find the 95% column, degrees of freedom 262, and we see anything past 200 will be 1.960. Evaluating that in the formula, and we'll get 5.53 minus 1.960 times 0.92 divided by the square root of 263. That's less than the mean, which is less than 5.53, plus 1.960 times 0.92 divided by the square root 263. Now, carefully type this into your calculator if you need to. Pause and do that. Looking at our notes, the notes give us a rounding rule. They say for this confidence interval, in this case, we would use a rounding to the same value as X bar was given. So for us, X bar was given to 2 decimal places. So for this case, it's 2 decimals. Type in calculator and rounding, and we'll get a value of 5.42 as a lower bound, 5.64 as the upper bound. Next, it says, assume the mean score for students taking traditional courses is 5.55. A college offers online courses claims the mean score for online and traditionals are the same. Does the confidence interval we found here contradict this claim? In this case, it doesn't contradict the claim because 5.55 fits squarely inside this interval. So because the given value is in our confidence interval, we can assume that the mean scores for online and traditionals are the same. So here we're going to say no, the confidence interval supports this claim. So for our next problem, take a moment to pause the video, attempt it on your own, unpause to check your work. So here we have a population has standard deviation sigma 12.7. Now, really quick, as I say this is sigma and not S, I'm going to take a note and say, I know the standard deviation. And the reason I want to take note of this is knowing whether we're dealing with a confidence interval where the standard deviation is known or unknown or population proportion. We go through a different process. We use different formulas. So just picking up on this context clue will direct me to how I should solve this problem and what formulas I should use. It says how large of a sample must be drawn so that a 96% confidence interval from you will have a margin of error equal to 2.5? Well, we know first things first, identify the correct formula. If you look back in the notes for the correct section, the formula that applies here is the sample size is equal to Z alpha over 2 times sigma divided by margin of error squared. And of course here, since we're getting a value, no matter what the decimal is, we round up to the next digit for our sample size. So I see that I've already got the margin of error, it's 2.5. I've already got sigma, it's 12.7. All I need to find is Z alpha over 2. Now that notation of Z alpha over 2 tells me I'm finding the critical value using my cumulative normal distribution. It's not T alpha over 2, which is students' T distribution. It's Z alpha over 2. So in order to help me find this value, I'm just going to sketch my standard normal curve. Now I want a 96% confidence interval, so that means the middle 96%. Now the tail makes up the remaining 4%. 4% is split equally, so that's a 2% on this side, which is an area. 2% as a decimal is 0.02. 2% remaining on the right side as a decimal, that's 0.02. And the way you'll find this critical value, which is what we're interested in, is what is the z-score whose area to the left is 0.02? Well, we'll use the chart now in reverse. So looking at my chart, I'm looking at the middle section, and I'm going to say which area, which middle portion is closest to 0.02. Here I see a 0.0202, 0.0197. Remember, when there's two that seem close, pick the closest, which would be this one. So that's from the negative 2.0 row, 0.05 column. So that's a z-score of negative 2.05. And then by symmetry, it'd be positive 2.05 for the other value. So here my Z alpha over 2 for 96% is 2.05. And that's what will go here. So now that we've gathered that, we're just correctly evaluating the formula in our calculator and rounding to get our final answer. 2.05 times 12.7 divided by margin of error 2.5 squared. Type that into your calculator, you get about 108.45, which we know we then have to round to the next value. No matter the rounding rules, for sample size, you always round up, regardless of the decimal place. So this is 109. It said if the required margin of error were 1.5, so if we changed our margin of error in, would the sample size be larger or smaller? Now in our section video, we talked about how you can kind of think through this, but if you're not super comfortable with that, just redo the calculation and make your conclusion. So I've got the formula. The new sample size would be the same critical value because it's still 96%, so 2.05. Same standard deviation, 12.7, but now my margin of error is 1.5. Type that into the calculator, we get 301.25, which of course, even though it's 0.25, sample size says round up no matter what. So that rounds to our 302. Now 302 is larger than the original 109. So we would say if you change the margin of error to be this, you end up with a larger sample size. So for our next problem, pause and attempt the problem on your own. Unpause to check your work. So here we've got a sample size of 64, standard deviation of the population 24.18, so our standard deviation is known. They ask us to find the margin of error if I had a 95% confidence interval for mu. Well, I go to the notes, confidence interval for mu, standard deviation known. There's a particular formula in that set of notes for margin of error. I record it. That is Z alpha over 2, which is your critical value, times sigma over the square root of n. Okay. Now, if you look back in this section of notes, you'll see that for a few common confidence levels, we can quickly find our Z alpha over 2 using this chart information. For a 95% confidence interval, the Z-score is 1.960. Now, if this was a less common confidence interval, like our last example where we were dealing with, I believe, 96%, that's not in the chart, then you saw the process of how you could find the z-score on your own. So remember, this table is a shortcut, not a necessary step. But if you have this information, it of course does make the problem faster. Just make sure you know how to do it the regular way too, in case you had a less common value for your confidence level. Everything else is known, so this is 1.960 times 24.18 divided by the square root of 64. Typing this into the calculator, we get 5.9241. That is my margin of error. Now it said if the confidence level were instead 98%, would the margin of error be larger or smaller? Well, in this section of notes, we went through how to think about that if you go back to this particular section video. But if you don't want to think through that process, just recalculate it with the change and see larger or smaller. So what has changed here? If we have a confidence level now of 98%, that gives you a different z-score. The z-score would instead be 2.326. Okay? That would impact this value. So we recalculate 2.326 times the same standard deviation divided by the same square root of n. Type that into the calculator and you get, when rounded, to about 7.030, which is clearly larger than the previously calculated margin of error. So our answer for this case would be, if you increase the confidence level to 98%, you would need a larger margin of error. So here's our next example. Be sure to pause the video and attempt this on your own. Unpause to check your work. So here I've got among 238 cell phone owners aged 18 to 24 surveyed by the Pew Research Center, 102 said their phone was an Android phone. Now, as I'm reading through, we're looking for context clues because we know in our confidence interval, we've got a few different methods. We've got confidence interval for the mean when the standard deviation is known, confidence interval for the mean when the standard deviation is unknown, confidence interval for our population proportion. And just from these context clues, the fact that I've got 102 out of 238, that tells me I'm dealing with population proportion. The sample proportion, my p hat, would then be 102 divided by 238. And because I now know I'm dealing with population proportion, that would tell me I need to get the confidence interval formula for that particular scenario. So let's write that out. So looking back through our notes, this is the general formula. Let's highlight the values that we know. We know our p hat, that's 102 over 238. We know our sample size n is 238. The only thing that remains is our critical value then, but 95% is a commonly known value. If you look back at the chart that we referenced previously, this is in our notes from this section, you can see the critical value when you've got a 95% confidence interval, z alpha over 2 would be 1.960. So if I can write this out correctly, now the biggest thing here is typing this into your calculator correctly without error. Once you write out all of this, it's just typing it in, making sure there's no problems, and we'll get our answer. And then looking back in this section of notes, we have the reminder that whenever we finish this, we need to round to 3 decimal places for population proportion confidence intervals. So carefully typing this into the calculator. If you haven't done that yet, make sure you pause the video and attempt this on your own. You need to not only know how to write down the formula, you need to be confident you can correctly use your calculator. So typing this in and rounding to 3 decimal places, you get 0.366 for the lower bound, 0.491 for the upper bound. So here it says assume an advertisement claim that 45%, remember 45% as a decimal is 0.45. You can always change a percentage to a decimal. Of cell phone owners in this age group have an Android phone. Does a confidence interval contradict this claim? Well, the confidence interval was the cell phone owners in this age group having an Android phone, and it said the sample proportion, or excuse me, the population proportion here would be between 0.366 and 0.0491. This fits well inside that interval. Since it fits inside the interval, the confidence interval supports the claim. So we'll say, no, it doesn't contradict. In fact, the confidence interval supports the claim. Only if the given value had fallen outside the interval would we say it contradicts the claim. So for instance, maybe like 80%. 80% is well outside the interval, so it definitely would contradict the claim at that level. So next, pause the video, attempt on your own, unpause to check your work. So here I've got a pollster wants to construct a 95% confidence interval, so I know I'm dealing with confidence interval. I then think, okay, I've got to identify which of the three types is it. Mean with standard deviation known, mean with standard deviation unknown, population proportion. So reading through, we are told that a poll estimates the proportion. Now, right when I see the proportion, we can be quite confident we're dealing with population proportion. And in fact, the proportion estimated is 0.34 from this survey. So my p-hat, sample proportion, is 0.34. Based on this estimate, what sample size is needed? So the confidence interval will have a margin of error of 0.03. So in this case, I'm not actually finding the confidence interval, I'm finding the sample size needed for a given margin of error at a different confidence level, 95. If you look back in your notes, there's a particular formula for this. And for the population proportion sample size formula, there's two cases. One if p-hat is known, one if p-hat is unknown. Well, we know p-hat. So in this case, I'd use the formula. You can find this in your notes. P-hat times 1 minus p-hat times z alpha over 2 divided by margin of error squared. Let's highlight what we know so far. We know p-hat. We know the margin of error is 0.03. So the only thing left to use this formula is my critical value. Well, a 95% confidence interval is a very well-known level. So looking back at our chart, you can see the confidence level is 1.960. So 0.34 times 1 minus 0.34 times 1.960 divided by the margin of error 0.03, square that, okay? You get about 957.839 when you type this into the calculator. Now when we're dealing with sample size, it says no matter what, if you don't get a whole number, round up. So here we're going to say that rounds up to our value of 958. That would be the needed sample size for a 95% confidence interval if our margin of error was 0.03. Now part B says do the problem again, but assume no estimate of p is available. So our estimate of the population proportion was our p-hat, 0.034. However, or 0.34. If you look at your notes, you'll see if no estimate of p is available, we're given the formula n is 0.25 times z alpha over 2 divided by margin of error squared. So the only thing that changes here is I've got my 0.25 times the critical value, because it's the same 95% confidence interval, 1.960, same margin of error, square that, type that into the calculator, you get about 1067.11. We, of course, round that up to 1068 because it's a sample size. So as always, if you have any questions about this material, first remember this is review. We went through things a bit quicker because we've already seen this chapter before. If you would like a more detailed explanation about any of these sections, look in the timestamp of this video and you'll see the sections listed out by time. Go back to that section video and you'll see detailed explanations. And as always, if you have questions, please reach out via our campus communication and I'll be very happy to help you.